Hello, everyone. Thanks to be here. So, first of all, I'm Matteo Ronchi. I work at WorkWave as software engineer, and at WorkWave we do mainly fleet management software. So we enable companies that own a fleet or rent fleet to do their business and plan their job. And last year we went through a big rewrite of one of our products. And we decided to rewrite it using modern technologies like React and all cutting-edge framework around. And while doing our evaluation on the architecture and how to design our UI, we discovered that none of the existing solution to theme in React was satisfying for our purposes. So we started digging into what was needed to create our own solution. And today I want to share with you our experience and hopefully give you some hint to avoid our errors or to start a better position for your own implementation. So first of all, we have to a little better understand what is the web today. So modern web is very different from 5 years ago, 10 years ago, and the biggest difference is that we slowly moved to a completely component-based architecture. And this change, this shift, happened slowly but continuously, and is motivated by a lot of small details that are very important in our day-by-day product life. So components enable us to be modular, to scale really, to reuse also. And most important of it, they allow us to abstract and sort of encapsulate our UI building blocks and really decouple them from a single product. So we can easily build a UI kit or a tool like that. When you start going down the road of a full component-based architecture, you start also recognizing that you need a different way to abstract and decouple reusable functionalities from UI elements. And that in React bring to higher order components and factories that enable us to define specific feature or functionalities and use higher order component to augment our own component when needed. Component is not a new concept. Also in front end, in 2006, Martin Koning said it was a longer phrase, but the important bit is that componentization is a seductive software development practice. And it is. When you start designing and thinking components, you see because why it's handy and why you want to do it. And more you do it, and better it became. But thinking about, speaking about styling, we have to think about different point of view. So there is not a single way to style a component. We have very many ways. The first and most widely adopted is plain CSS, with or without preprocessor, Sass, less, doesn't matter. But plain global cascading style sheet loaded by our browser before or during the loading of the page. That approach works well, is perfect for small and also medium-sized product. But if you scale, if your product is very big, it became a mess very fast, because you have to define everything you need ahead of time and use those information with very little room for live tweaking or other option. So in the front-end development, we introduced and created CSS module. I don't know if you know what CSS module are, but it's a great advancement because CSS module allow us to encapsulate our CSS, still plain CSS or pre-processed CSS, with our component. So we bundle together the UI, the interaction, and the style. And this is fine. You can take your component folder, move it to another project or in another part of your scaffold, and everything works fine. The problem with CSS module, the only one I ever had, is when you need a lot of live tweaking of properties. If you need to change often color, font size, or small detail in a lot of classes. At that point, you still have a mess of CSS rules inside your own, or your components. And so we started in the React community working a lot with inline styles. Someone of us love it, someone hate it. I'm mainly agnostic about it. But inline styling are very good for live tweaking and for allow us to change dynamically based on our component state and application workflow, the UI result. So in this example, we have a plain object, color red, that is applied to a button. We can easily change the value of color to whatever we want, and the browser will re-render everything. Inline style have some major drawback. Performances, first of all. So if you have a lot of inline style and a lot of animation, performances are not ideal. And also, we miss some very important CSS feature, like pseudo element and the ability to react to different screen and sides. So very recently, I'd say the start of 2016, a new kind of CSS in JS framework started to appear. And those are the runtime generated CSS kind. We have some very well-known library. Style component is the more famous, then Aphrodite, Styletron, and Glamour. And all of that libraries allow us to write plain JavaScript object and get in the browser real CSS with media query, pseudo element, and whatever we need from real CSS. They are slightly less performant than pure CSS, but if you are creating a web application, not a dynamic website, the drawback of the first couple of seconds having your animation not so smooth normally is not a problem. If it is, probably that is not the right solution for your application. Once we start styling, we need to move forward and think about theming. So theming is the idea, the concept of abstract our need on a visual standpoint, color, fonts, repeating pattern, and like padding and margins, and apply them in a consistent way across all our views. It's simple to do, it's simple to explain, it's very hard to maintain. And this is one of the biggest challenge of a small product that grows becoming big project, in my experience at least. And like component styling, UI theming can be done in a very huge array of possible different ways. And often is our own project that determine what is the right approach to choose. So one very well-known example of theme is a color palette or a generic palette. So we define some basic information like color, font sizes, padding, and this is less, for example, and we assign those values to some variable. Every time we compile our CSS, we get the updated value, but we don't have to touch every single class manually. And this is a big improvement, but still doesn't scale a lot. It's just a good foundation for a more complex solution. And being that we use component and we are in React or Angular in a dynamic environment, we can benefit from component properties. So our components normally are rendered and defined by their own properties. When a property changes, React re-render the component and produce the updated output. We can leverage that situation to create more complex theme management approaches. This example uses styled components. So we define a simple theme object. This is plain JavaScript object. And two arrow function that dynamically, based on the component properties, choose what kind of information from the theme use. And then inside the style div template string offered by styled component, we pass those dynamic selector that will be invoked by styled component every time the component will receive new properties. And those properties will be passed to BG style and font style that will be able to compute the right style and produce the desired output. This is nice, this works very well, but in my personal opinion, it became a little messier when you have a lot of rules inside your class and all of them are dynamic, because you start having a template string with 10, 15 sub-functions to be controlled and maintained. But it works very well, nonetheless. But as said, at WorkWave, we felt that it wasn't enough. To be honest, styled component wasn't a real thing when we started our own solution. So it wasn't a viable option for us. It was just being made the first commit, if I recall correctly, of styled component. So we looked for something different, for something more powerful. And some of our requirements were, for example, the need to change the whole theme at runtime. So we have a situation where we want to swap the whole look and feel of the UI without reloading the real UI during the user experience. And this is something that most of theme manager and theme system doesn't support very well. And also, we wanted to decouple our styling from the component. So I love JSX and HTML inside JavaScript, but we wanted to decouple the pure styling logic from the reusable component to make it really reusable. So our style information and logic is outside the component and consumed by the component. Also, we need situation where, for example, I need to open a modal, and I need that this modal and all of its descendants implement a different theme. So my application is using the red theme, but I want that particular modal to use the blue one. And dynamically, all the descendants must reflect that need. And this can be done, but is not that easily accomplished always. And last but not least, we want, in the end, be able to use atomic-css. So I don't know if you know what atomic-css is a little out of the scope of this talk, but is a way to define styling, creating single instruction CSS classes and composing those classes together, reusing always the same building blocks. Is more or less the same that we do with component, but with styling rules. And so we created our own solution. Right now, we don't have a real name because we are working with our legal team to open source it. And so right now, we are not open source, but I hope to make it real very soon, because I would love to work with other people, have different point of view on our implementation. So Our theme manager is the engine responsible to own and expose at least one theme or several. That depend on the application using it. And every application or every code you write can subscribe to your theme manager and be notified every time the active theme changes for a what you see, what you get application, for example, or if the active theme is being changed. So we are swapping the blue theme with the green theme, for example. And starting that way, we are able to propagate to the whole UI our changes without having to go through iteration or complex controls. Every theme exposed by our theme manager is composed by two entities. Styles, that is the required part, and is the actual theme. So we will see better in a moment, but it's a plain object, a map of map. So we divide our theme in categories. What you put inside a category is up to you. Could be a component-based approach, so we have the button category, checkbox category, slider category, and inside the category, the specific classes definition. Or you could go atomic and create a font category, a color category, padding category, and name those kind of styles by their use, being more semantic. And then we have presets. Presets are a sort of predefined override for the base theme. So we have our cool theme, but we need a darker version, or the lighter version, or a disabled version. And the changes required for having a dark version are very small, but affect the whole theme. So we create an equal object with just the key we want to override. And then at runtime, we merge the preset over the theme, and we get a different look and feel, but with really, if not zero, a minimal effort. So I'm not sure this bit is big enough. Let me zoom it. So this is a very basic idea of what our theme could be. So this example uses component-based approach. So inside style, we have a button category that exposes a single class button with a background, a color, and et cetera, et cetera. This is a valid approach, is the best one when you start developing the UI, because it's very fast. You don't have to create a lot of rules or standards. You just write your style. But in my experience, at a certain point, you start to having more work maintaining that approach than benefit from having it. But again, this is a dark preset that slightly change our style. So we have 4 rules inside our button, but just 2 rules that override or change the final result. And being a plain JavaScript object can be serialized as a JSON, can be server-side provided or tweaked. And that was important because we plan at a certain point to have per user theme customized, and we want that every user by its own ID will preload its own theme rules, shared per company, team, or user, or whatever they want to. And this is the same example, but using atomic CSS approach. So we have a color category with normal and confirm, and a background category with normal and confirm. And in the dark theme, we just override the confirm semantic naming. So we don't want to change the normal state, but the confirm button or action will be different. And you can make fit any mixed solution you want. We are not forced to use just one approach or the other. We can use both of them, sharing the most generic rules as atomic rules, and the more specific one has component-based one. Right now, we are doing that in our product. So a themed component is the component that expect to work with our theme manager. And this component expect to receive a map of CSS classes. So our idea is that, like with CSS module or plain CSS, our own component knows what classes it needs to use, because they are predefined. What we do our code is the content of those classes. So if we want that the background class is a black bordered background or a red and white bordered background, we can do it in the theme part. Our component just will receive a plain object with the key background, header, footer, whatever, and we'll apply it to the UI. Then we have React binding. I don't know if any of you have ever used Redux and React Redux. We have tried to follow the same approach. So we have a theme provider that is a component that must wrap, if not the whole application, all the themed part of your application, and is responsible to own and expose a theme manager instance. So when we start the application, we create a theme manager, passing to it at least one theme, and we expose to all the descendant component using React context the theme manager. That way, we also gain the benefit to have more theme manager. I don't see a real-world application for my product, but in other situations, you could benefit having two separate themed applications working aside instead of a big, huge theme with a lot of non-related information. We can also override per component. So if a given component requires a different theme manager, we can simply pass it to it, and starting from that component, all the descendant will have it. And then we have the connect theme higher order component. That bit allows us to configure how our themed component will connect and react to our theme. So we have to pass it a configuration object to define the bare minimum information required to the framework to react and pass the correct information, and a map theme to props function. Then we get back a higher order function that accepts a component and will give us back an augmented one. So this is a real example of how we can use the connect theme. So we create a config object. Right now is not ideal as syntax, but we are stick with that for now. We have to pass an array of types. Those types are the categories. So header will have been defined as button or colors and backgrounds as top level in the theme. And our connected component explicitly requests only the part they need. This is important for performances because we don't want to recompute our styles in every component when something not related to them changes. And then we have map theme to props. In this case, we don't compute nothing. We just take, as they are, the wrapper and label object, and we pass those objects down. Those objects will be passed to a post processor that is pluggable. We will see it better in a few minutes, that compile your JavaScript object using CSS in JS notation to real CSS. Right now, we are using Aphrodite to do that part of the job, but we are moving towards Styletron that is more performant for our needs. But we could use both of them. It's a pluggable system, so we can do whatever we want. The themed header component we get will pass down a CSS prop to the wrapped header component. By default, our theme connected higher order component use the CSS name to create a prop that represent our map of class names. But it's configurable. You can call it whatever you want it if it clash with your own implementation or you don't like it. That way, we are using CSS wrapper for the outer div and CSS label for the label rendered. And those information will never change until our own component will change. And in the style part, we can simply change what rules are applied to those classes. Map-theme to props has this signature, and like other higher order component in React, accept our own side of the data, that is the theme part we requested for. So if we ask for header types, we will get a theme object with a single key that is header. And then we can, if we want to use, accept the component prop. So if we define the prop argument, every time the component props changes, we will get our map-theme to props recomputed for us. This is a minimal example of what we can do with map-theme to props. So we receive the theme without the prop in this case. So in the average application, that function will be executed once. Because if we don't do what you see, what you get live editing, our change is created at the begin or loaded from the server at the begin and simply used. We also memorize those functions. So until the input object will not change, we will never re-execute the computation, but we will give you back the already computed value to increase performances and don't waste time. In this case, we are composing color and backgrounds to create 3 classes. So we have wrapper, normal button, and comfort button. And those are not defined in our theme. They are specific for this component, but they use the theme information to create our desired classes. And then we have a decorated component that simply use, again, those classes to render the desired result. This is the same example, but using prop. Let me zoom it a little. It became a little more verbose, but we can react to props. And so we can choose, for example, if we are in a disabled state or an enable one, and react properly, applying or removing certain CSS rule we define. This is a very minimal example, but it's just to show the idea that if we can compose basic building block of styling for our application, we really get a pool of small pieces to compose and reuse in any component. Then the decorated component is also further configurable if you need to, using a themeParam prop that the augmented component support. This property accepts an object with 3 fields: preset, theme name, and overrides. And those 3 fields allow us, on a per component basis, to change the active preset for the component and all its own descendant. the active theme, the whole theme, or simply manually change a bit of the code. So for example, using the previous example, we can force on a component the dark theme and manually change the normal color for backgrounds and other stuff. Doing that way, we are really in control of everything we need to tweak. So it's more verbose, we know that, and we are trying to reduce the verbosity, but you gain, when your application scale, right now we are around 20,000 lines of JavaScript and around 300-400 components. When you start scaling, you really start having less work to maintain or change the whole application style or look and feel. And as I said before, we are making the decorator pluggable. So you can define, for now, a single post-processor, but very probably we will make it an array so that we can tweak and apply more post-processor, like a middleware chain in the server, and control the output. For example, in some situation, we don't want the real CSS computed, but we want the CSS in JS object. Because for some performance reason, we don't want to create too many CSS classes with just a small variation. And in those cases, we use inline style, so we mix both. But the nice part is that the theme manager doesn't force us to do only one or the other approach. We can use both of the world based on our needs. And also, as said, we try to memorize and avoid non-useful computation, doing a quite aggressive caching of data. You can disable it if you want to recompute always, but I don't see very many situations where that can be useful. And so we know, I said, that we can improve. We are trying to make the syntax better before we will open source it. I hope really we will be able to reduce a lot the boilerplate, and also we would have a nicer way to define which categories of the theme we need to access. Now, sorry, here. Let me start the server. A second. I want to show you a live working implementation to give you a glimpse of how he behaves. Come on. Okay. So this is one of our, let me zoom a little. Okay. This is one of our UI kit component, and we needed a circular progress bar with configurable icon or content. We used those components over Google Maps, so we needed to be performant because we have thousands of those, but we needed to be configurable. And in this example, our base map theme to props function expect a styles prop that is used to configure and change the CSS we apply. So for example, we could go, and Joe became with a yellow text, or our red one, and etc., etc. So the auto reload part is a nice side effect of the style guide library we use, that is the React Style Guidist. And if you want to try a new one, this is a really good product. And the guy maintaining is a very nice person. But what you are seeing is our own implementation tweaked to get the border and the text changed. And being dynamical, we can also dynamically change. So the progress bar is an SVG dynamically rendered, but also dynamically styled using real CSS in this case. So this is not maybe the biggest example I could give you, but sadly, I cannot show our work in progress product at the moment. But this is it. I hope it's been interesting and not boring for you guys, and it will help you on your own experience on theming in React or JavaScript overall. Thanks again. Okay. Ooh. Near that.
So what would be the runtime overhead? So if you compile everything, right, is it as fast as normal CSS, or is there a lot of extra JavaScript, like 50 kilobytes of extra JavaScript to?
No, there isn't much extra JavaScript, because the only extra part is the JSON you load for the real theme, but you can gzip it and compress it, so normally it's not that much more that having plain CSS defined manually. And the JavaScript you write is not that much. So no, we have hundreds, if not thousands, of nested and decorated components, and we never saw any performance drawback or degradation. And we render really thousands of points over Google Maps. That is not the ideal environment for React. So no, I'd say that you don't, okay, if you care really much of your kilobytes, probably you get something extra. But if you, so if you are targeting mobile user in a 2G connected area, it adds a little overhead. But if your target is a desktop user that uses your product for back office or daily work, you get very few kilobytes extra that they never see are there, because it's very half second more or less.
Yeah, I think the back office people are not the issue, right? It's the mobile, even on 3G,
exactly.
That is, if you have a poor 3G connection, then the kilobytes really hurt.
Yeah, I know most of our world today is not in 3 or 4G connection, but also I would design the application differently in that case. But our focus in our particular situation is a desktop application consumed using the browser. But it's a full HD screen application, and it's not meant to work very well on mobile also. But
thank you.
You're welcome. Any other question? Okay, so thank you very much, and enjoy the rest of the conference.